Another quite fascinating visualization that the tensor board provide is what is called as embedding projector. So the tensor board offers an embedding projector to visualize data in 2D or 3D using algorithms like PCA and TSNE. So we know that these algorithms, PCA and TSNE, are used for dimensionality reduction, right? So this the embedding projector functionality that is available in tensor board help us to visualize very high dimensional data. So I will show you an example wherein which I have created a program to visualize the MNIST data set on a tensor board. So MNIST data set is a computer vision data set, or it is a data set that has images. It has images of handwritten digits. So it is a high dimensional data set, and so let us see how we can visualize this high dimensional data set into a 3-dimension using TSNE and visualize that through tensor board. But of course there are limitations to this projector. It cannot handle very large data samples, so there is a restriction on the number of rows that this particular that a particular data set has to have if to be visualized through a projector. And also it does not show colors for more than 50 classes. So if your data set has more than 50 classes and you wanted to show each of the data points belonging to these 50 classes by a separate color, then if it is more than 50 classes, it does not show the colors, right? But in the case of MNIST data set, as we know, the digits are only from 0 to 9. We have just 10 classes. So let us go ahead and visualize this MNIST data set using a tensor board. So I have already have my code. I will just run my tensor board. So my tensor board is up running. So let's see. As you can see, so this is my projector, embedding projector for my MNIST data set. So this is PCA. It has used PCA in order to do the dimensionality reduction. We can even make it very fancier on this light mode. So I'll just go here and I would say color by label, so that I have 10 different colors. So when you hover through it, you can see what are the colors that are belonging to each of the classes. Let us go to this TSNE and we can start training it so that we can actually see how that clustering happens. So let's see. It might take a while, just few more seconds. So as you can see, it has started training iterations 20, 21, as you can see. And here you can see that the number of records are 10,000 and the dimensions is 784. Dimension 784 means that there are 784 columns in your data set. So you can see how it is training. And I can also search labels here. So I say 5. So you could see how 5 is clustered. Or if I say 9, see how 9 are clustered, right? So as the iteration progresses, you could see that these values becomes more clustered to each other because they belongs to the same class. So let us stop the iteration for now and see. So see, this is how my data points are clustered and its dimensionality is being now reduced, right? So I can also move from 3D to 2D. So it is now 2D. I can again start doing my iteration, but this happens in like a 2D, so we don't get that 3D feeling, but still it's quite impressive. So let us stop. And as you can see, when we click here, we could see what are the labels that belongs, right? So one is clustered like here. So again, there are more interesting features to TensorBoard. If you feel interested by these visualization, what you can always do is whenever you build a neural network using a TensorFlow, you could also build a TensorBoard so that you can do some fancy visualizations like this.